A black hole is known for its incredible ability to consume everything that crosses its path. But what's even more astonishing is its power to eject a column of energy at astonishing speeds, in almost a straight line with minimal deviation. In energy filament theory, the energy jet expelled by a black hole is actually a stream of particles that are straightened by extreme dimensional forces. The key to this process lies not in the black hole's aggression, but rather in a specific internal structure it possesses called a dimensional corridor. This corridor can be understood as a tunnel in the fabric of the energy sea, where the dimensional alignment is perfectly coordinated, where resistance is reduced and the path becomes nearly straight. Once particles and disturbances are funneled into this path, it becomes far easier for them to travel in a direct line, shooting out into space. In this theory, the majority of the black hole's outer surface is made up of what's known as the critical outer skin layer. This is where the pores of the black hole constantly open and close, letting out dimensional pressure in a controlled manner. Imagine the small vent holes on the lid of a pressure cooker. There's a constant release of energy, but the direction and flow are disordered, making it difficult for any energy to be expelled in a specific, concentrated stream. However, as the dimensional waves of the black hole increase in strength and force, the question arises: which path is the most efficient, stable, and least likely to tear apart? The answer is found in the poles of the black hole's rotational axis, where a permanent dimensional corridor is formed. When the black hole spins, it stretches the surrounding dimensional field into a flattened, disc-like shape. The orientation of this disc is complex and constantly shifting, making it difficult to maintain a straight path for energy. But it is in the regions near the poles of this disc, where the dimensional forces are most concentrated, aligned, and not as distorted by the rotation, that this corridor becomes possible. These poles act like an internal cosmic nozzle, guiding the particles and energy in a direct line. Inside the black hole, the core is constantly bubbling and churning with activity. The piston layer continues to push dimensional waves outward, while the pores of the outer critical layer release energy in small bursts. Yet, once a particle enters the dimensional corridor near the poles, it gets accelerated and straightened out, similar to how water gets forced through a high-pressure nozzle. The result is a concentrated jet of energy, which can shoot out for hundreds of thousands of light years. Thus, black hole jets aren't the result of some random rupture, but instead a carefully orchestrated process involving the gradual release of dimensional pressure from the pores in various directions. As the pressure builds, a dimensional corridor forms at the poles, guiding the particles into a long, narrow, focused stream. The jet is effectively an efficient, controlled release of energy. In summary, the black hole's energy jets aren't just random eruptions but a result of the gradual buildup of pressure and the creation of a steady and stable corridor for the energy to travel through. The larger the black hole, the more it acts as a stable cosmic engine, churning out energy in these fine-tuned jets. Next time, we'll discuss the incredible consistency of black hole jets, why they always appear perfectly aligned, like cosmic lasers, and why this phenomenon is so consistent across the universe. Tap follow, share it on New Physics, Clear Universe.